The topic for today is software design introduction. Software design encompasses the set of principles, concepts, and practices that lead to the development of a high quality system or product. Software design is an iterative process through which requirements are translated into a blueprint for the construction of the software. The goal of design is to produce a model or representation that exhibits firmness, commodity, and delight. To accomplish this, you must practice diversification and then convergence. Design is the place where quality is fostered in software engineering. Design provides you with representation of software that can be assessed for quality. Software design serves as the foundation for all the software engineering and software support activities that follow. In today's video, we are going to discuss the introduction to software design. Let us start. Welcome to our channel Engineering and Technology for You. If you are not subscribed to our channel, kindly subscribe and press the bell icon so that you get notifications for our future videos. The topic for today is software design introduction. Let us start with the introduction. Software design is the process of envisioning and defining software solutions to one or more sets of problems. So in software design, we are trying to provide solution to one or more problems which are there existing. So the software design, it actually encompasses a set of principles, concepts, and practices. So these principles, concepts, and practices, if you follow, it will lead to the development of a high quality system or product. So here high quality system or product may mean the software. Now we have gone through the requirement analysis and specification phase. So during this phase, the requirement of the customer are analyzed and finally documented in a software requirement specification document, that is called as the SRS document. And during the software design phase, the design document is produced based on the customer requirement as documented in the SRS document. So here if you look at this figure, we have the SRS document and the design process will convert this SRS document into a design document. So here the design process starts using the SRS document and completes with the production of design document. The design document produced at the end of design phase should be implementable using programming language in the subsequent phase, that is the coding phase. So when we are having the SRS document, it contains the requirements of the customer. So we are in the problem domain here, and the things which are there, they are defined by the word part, whereas in the design document we are in the solution domain. So here it contains the answers to these problems. So it will be how we are going to implement them. So the word will be how here. So this is how the design process will convert the SRS document into the design document. And let us go further. So translating the requirements model into the design model. Now here each of the elements of the requirement model provides information that is necessary to create 4 design models required for the complete specification of the design. So how the information flows, that is illustrated in figure on the next slide. So the requirement model manifested by scenario based, class based, behavioral elements, they will be feeding to the design task, and then using the design notations and design methods, the design produces a data or class design, an architectural design, or an interface design, and a component design. So these are the 4 ways in which the design models are produced from the requirement model. Let us see the diagram. Now here we have these 3 elements: scenario based elements, then behavioral elements, and the class based element. So this is the requirement analysis phase. Here the analysis model, the scenario based elements, they are analyzed with the help of use cases, that is using text or use case diagrams, then activity diagrams and swim lane diagrams. These are the methods for analysis of the scenario based elements. Similarly, the behavioral elements, they are analyzed with the help of state diagrams and sequence diagrams, and the class based elements, they are analyzed with the help of class diagram, analysis packages, the CRC model, the class responsibility collaborator models. So the collaboration diagrams are drawn in that. So all these methods, scenario based, behavioral, and class based elements, they are feeding the input to the design model. So these inputs are given to the design model, and the design model, say here we have the data or class design, architectural design, interface design, and component level design. These are the 4 different levels in the design model. So the data or class design transform the class model into design class realization and the requisite data structures required to implement the software. Then the architectural design. Architectural design defines the relationship between the major structural elements of the software, the architectural styles and the patterns that can be used to achieve the requirements defined for the system, and the constraints that affect the way in which architecture can be implemented. So that's why we'll have to choose the architecture depending on the implementation issues. Then the interface design. See, any software communicates with the system, that is the hardware, or with the humans with the help of the interface design. So the interface design will specify that. And then last we have the component level. So here this component level design will transform the structural elements of the software architecture into a procedural description of software component. Information obtained from class based model and behavioral model serve as the basis of component design. So the components are designed in this component level design. So in this way, the design model overall, it will have the say data or class design, architectural design, interface design, and the component level. All these 4 elements. So Next, we switch on to the diversification and convergence. So when we are into the design, diversification and convergence, these are two important things. These are the processes which are followed for the design. See, the goal of design is to produce a model or representation that exhibits firmness, commodity, and delight. So, in order to accomplish this, you must practice diversification and convergence. So, what is diversification? So, diversification is nothing but different methods we follow for the solution to the problem. And once we have the different methods, then we try to take the best method from that. That is nothing but the convergence. So here the Pilodi, he has stated that diversification is the acquisition of a repertoire of alternatives. That means different methods or alternatives for the same problems. And here the raw material of the design, that is components, component solution, and knowledge, which are there in the catalogs, textbooks, or in our mind. So they are tried. So with the help of these different things, we try to present diversified solution to the problem. So once this diversified solution set of information is assembled, you must pick and choose elements from the repertoire that meets the requirements defined by the requirements engineering and the analysis model. That is nothing but the SRS document. That means we are trying to find out the different solutions to the requirements which are documented in the SRS document. And this different or diverse set of solutions, they are assembled, and then we choose different elements from it. So as this occurs, alternatives are considered and rejected, and you converge on one particular configuration of the component. So this will be done with the help of things like brainstorming. All the members or the stakeholders, members of the team and the stakeholders, customers, they will sit together and have a discussion, brainstorming session, and then they will come on a particular configuration of the components, and that will the final product will be created from that. So that's why this diversification and convergence is important in the software design. Then the design process. Here we are going to just see the overall design process, what it is. Software design is an iterative process through which requirements are translated into a blueprint for the constructing the software. Here blueprint is nothing but the model or diagrammatic representation of what is being done in the software. So initially the blueprint, it will show the holistic view of the software. That is, the design is represented at a high level of abstraction. So here can directly trace the system specifications and objectives, and more detailed data, functional and behavioral requirements directly. Then as the design goes into the different iterations, then refinement will lead to the design representation at a lower levels of abstraction. So then in that case, the requirements can be stressed, but not directly. It will be subtle or indirect. So this is how the design process will take. Then let us summarize the software design. The importance of software design can be stated with a single word: quality. Because the quality of the software will depend on the design. So design is the place where quality is fostered in the software engineering. So it provides you with the representation of software that can be assessed for quality. So that's why it is a very important phase in the software. So as you can see, different softwares which are available. Even if you go for the web-based softwares or mobile applications, you can distinguish between the quality from the design. Then design is the only way that you can accurately translate the stakeholders' requirements into finished software product or system. So the translation of requirement, that is the from the SRS document, software requirement specification document, into the say design model. So that is done with the help of design process, and the accuracy or the quality in the design will determine whether you are translating all the requirements or not from the SRS document. Then software design serves as the foundation for all software engineering and software support activities that follow. That's why it is serving as a foundation for the software engineering. That is nothing but the other activities which are to be followed. That is testing, coding, testing, and then deployment and maintenance of the software. So if your design is a high quality design, then that will make the other activities good. Then without design, you risk building an unstable system, so one that will fail when small changes are made, one that may be difficult to test, one whose quality cannot be assessed until late in the software. So here, that's why the design phase is very important, and that will determine the quality of the software. So with this, we come to the end of this video. If you have any questions, you can contact me on Facebook, Twitter, Gmail, or Instagram, or you can go to our website engineeringonlineforyou.com and watch the videos there. Then if you like the video, press the like button, share with your friends, and subscribe to our channel Engineering and Technology for You. And don't forget to press the bell icon for getting notifications about our future videos on this subject. Then thanks for watching. Have a nice day.